Welcome back to our course in trigonometry. Dr. Tom McNamara here again, working on my document camera today. In this video, we are going to talk about combining period changes with horizontal shifts. Okay, the horizontal shift affects the x-axis. It affects you in the horizontal direction. And so does this. Okay, so it's very important that we do these, apply these in the appropriate order. Because if we shift first and then do a period change, which is going to stretch the x-axis, that will change how far the graph is shifted. Okay, so here's what we need to do. We need to rewrite this function. So sine 3x plus, and then we're going to need to fill in a blank here. And whatever we end up having to put there, that's going to be our horizontal shift. Okay, now the question is, 3 times what gives us pi over 2? Okay, so we got a little equation to solve here. And of course it's not hard to solve. You just divide both sides by 3 and get that you need a pi over 6 over here. So this would be pi over 6. So that's our horizontal shift. And remember, when you subtract, that moves your graph to the right. When you add, that moves your graph to the left. So we're going to do pi over 6 units that way. All right, so let's make our little summary of all the information. So amplitude, period, horizontal shift, vertical shift. Okay, so looking at this formula, there's nothing added outside, so there is no vertical shift. Not applicable. Horizontal shift, whoops, I had that going the wrong way. It's pi over 6 units to the left. I think I said the right thing, but wrote the opposite of what I meant. Amplitude 4, period, 2 pi over 3. Okay, so putting all that information together and drawing our picture. Okay, let me give myself some nice space right there. And we'll go, I don't know, we'll go right here. Okay, now I do need some space on this side. Because remember, I need to start over here at negative pi over 6, okay? Your vertical or your horizontal shift tells you where to start the cycle. And this tells you how long the cycle is going to be. As always, we're going to divide that into 1, 2, 3, 4 pieces. Okay, we always divide the period into 1, 2, 3, 4 equal parts. My amplitude was 4, so my graph is going to live between negative 4 and positive 4 on the y-axis. Okay, now if I take that 2 pi over 3 and divide it by 4, that's going to give me pi over 6. Okay, 2 pi over 12 or pi over 6. Okay, so I'm going to change my picture just slightly. Okay, so Okay, so pi over 6. So negative pi over 6, I'm going to put that right here. That's another point on my 1, 2. Okay, so these should be my tick marks. This is more appropriate here. Okay, so I've divided my period into 1, 2, 3, 4 pieces. Notice here I'm ending at excuse me. Notice here I'm ending at pi over 2, and here's the reason. Okay, pi over 6 left, and by dividing my period into 4 pieces, I saw the tick mark should have been every pi over 6. So if I'm starting at minus pi over 6 and going pi over 6, that takes me to 0. And then pi over 6, 2 pi over 6, 3 pi over 6. I guess we can simplify the 2 pi over 6 to pi over 3. And 3 pi over 6, of course, is simplified to pi over 2. All right? Now we're starting here. Okay, why am I starting there? Well, we're graphing the sine function. Sine function starts at the midline. And then here we're going to go up top, back to the midline, bottom out over here, and once again back to the midline. Connect everything with our nice smooth curve, and that is a complete graph of the function y equals 4 sine 3 times x plus pi over 6. Okay, remember how the function actually started. 3x plus pi over 2. But remember, you got to unravel the period change from this horizontal shift. And this is how you need to do it. Factor out the period change and then deal with the horizontal shift after that. And you can always factor out whatever this number is, okay? Let's do one more example. Okay, so this function has a vertical shift, it has a change to the amplitude, it has a change to the period, it has a horizontal shift. We got everything in here, so let's get down to work. Period 1. Okay, where am I getting that? Well, you take this multiplier and you do 2 pi over that. In fact, maybe I'll write it down. 2 pi over 2 pi equals 1. That's the period. Amplitude. Amplitude is 4. Remember, you get the amplitude from the multiplier out here. And of course, amplitude is always positive. It can never be negative. Vertical shift. This does have a vertical shift. Up 2 units. Horizontal shift. Okay, now here's what we got to do to figure out the horizontal shift. We're looking to make 2 pi x minus pi over 3. We want to make that look like 2 pi times x minus something. Okay, what do I have to put here to get pi over 3 after I multiply by 2 pi? So in other words, 2 pi times what equals pi over 3. So that implies the box should be 1/6. Okay, take this, divide by 2 pi. So x minus 1/6. Okay, so the horizontal shift is 1/6 to the right. Okay, I'm just drawing little arrows to indicate the shifts. Okay, so we're going to put all this together into our picture. Okay, so we got a shift up of 2 units. That's the vertical shift. Okay, we need all this information in here, up 2 units. So 1, 2. So this is my midline. I'm going to draw a little dashed line right here. Okay, there's my midline. Now I'm allowed to go 4 units above or below this midline. 1, 2, 3, 4. So my max height will be 6. 1, 2, 3, 4. Min -2. Okay, 4 units above. Well, if you're starting out at 2 and you go 4 units above, you're at a max height of 6. If you go 4 units below, you're bottoming out at -2. Okay, so there's 1/6 on the x-axis. Now, our period was 1. So we're dividing this up. We're dividing that period into 1. Let's do it like this. We're dividing that period into 4 units. So 1, 4 units. My cycle is going to end there. So this is 1/6. Each of these will be 1/4 of a unit. So let me do some calculation here. 1/6 plus 1/4. Common denominator of 12. So that's going to be 5/12. This would be 8/12. 11/12 and 14/12. Okay, I'm just adding 1/4 to each of these. All right, so let's get our graph here. And remember, for reference, we are graphing y equals 2 minus 4 cosine 2 pi x minus pi over 3. Okay, so we're dealing with the cosine function. Note that negative multiplier. That means we are starting at the bottom. We're starting down here. We go to the midline. And we go up top, back to the midline, and then to the bottom. Okay, don't be tempted to go here. I know a lot of times we go to the x-axis, but that's when the x-axis is our midline. In this example, our midline is 2 because of the vertical shift. Okay, so now we go and we connect these points with our nice smooth curve, and that's our graph. Okay, so as before, I recommend you look at your formula, make yourself a little table here with all the key information. Write down the amplitude, period, vertical shift, and horizontal shift. Once you have that, then you're ready to draw your picture of the graph. Okay, this incorporates the vertical shift, which is where we're starting our cycle. The period is 1, so we are ending our cycle 1 unit past the start of the cycle, which we decided was 1/6. Yeah, okay, 14/12, which does equal 7/6. Okay. Okay, that's a 14 there. It's very tiny. Sorry about that. Okay, so, well, how do I know that 7/6? Well, I took my period length, which is 1, plus the starting point, right? 1 unit beyond 1/6. So I go 1 unit past my start. And I always divide my period into 1, 2, 3, 4 pieces so that I know where to put my anchor points. We're dealing with cosine, so we start, well, it would normally be at the top, but see that negative? It's a vertical flip, so we start at the bottom. Go to the midline, up top, back to the midline, and hit the bottom there. Okay, so the key idea from this video is remembering to unravel the change in period from the horizontal shift. You've got to do that first. Otherwise, if you try to do the horizontal shift without accounting for that dilating factor, you're going to be moving to the wrong place. Okay, so separate everything out in this little table, and it'll help you draw accurate graphs.